we need to show that angle AOB, this angle here, we need to show that that's equal to 1.186 radians. The way I'm going to do this is I'm actually going to work out this angle. I can do that reasonably easily because I'm going to focus on this little right angle triangle here, where I know that this is 1.5 because of the CD being 1.5, and I know that this is 4 because that is the radius of the sector. So that allows me to work out this angle here, theta, because I can say that sine theta is equal to the opposite divided by the hypotenuse. So if I do sine inverse of that, making sure your calculator is in radians, we get 0.384. I'm now going to take that away from pi over 2 because we've got a right angle here, and a right angle in radians is pi over 2. So if I do pi over 2 minus the 0.384, we get 1.186, which is the angle that we needed to show. So that's part A done. Right, part B says to find the perimeter of the garden. So perimeter around the outside. So some of these lengths I know already. For example, I know that this is 4, and I know that this is 6, and I know that this is 1.5. So we can add those together. 4 plus 6 plus 1.5. The two bits I don't know yet are the arc length here. Now I can work that out reasonably easily by using the formula that the arc length is the radius times the angle. So that's going to be 4 multiplied by 1.186, which is 4.744. And the final length that we don't know yet is the BC. So now I'm thinking, how can I work out BC? Well, I know that the whole of this length here is 6. So if I could work out what this length here is, I could take that away from 6, and that will give me the length of BC. So now I'm looking at this right angle triangle again and thinking about a little bit of Pythagoras to work out that red length there. So 4 squared minus 1.5 squared, all square rooted. So that length there is 3.708. So therefore, this length here is going to be 6 minus that, which is 2.2919. And so that is the length of BC. If we then add all of those lengths together, we find that the perimeter of the shape is 18.5 meters to 3 significant figures. And then for part C of the question, we want the area of the garden. So first of all, area of the sector. I can work that out using the formula half r squared theta. So that's a half times 4 squared times the angle, which was 1.186, which gives me 9.488. So that's the area of the sector. We now need the area of the trapezium here. Let me just draw that out just to make that trapezium super clear. You could do it as a triangle and a rectangle if you want, but I'm going to do it as a trapezium just so the calculations are easier. So, using the formula for the area of the trapezium, we've got half of 6 plus the 2.2919 that I worked out before, times 1.5. Which gives 6.218925. If we add that together with the sector, we get that the area of this garden is 15.7 metres squared.